Alright, so this video, guys, I'm going to go over just how to test for the different types of symmetries, let's say without looking at the graphs, right? So let's go over symmetry real quick. Symmetry is just pretty much when um, you're looking for where, I guess you could say, where there's a mirror image of your function on both sides of an axis, or a flipped mirror image across your origin. Okay, so what I mean by that is that let's say we had a function that looks like this. So you guys are pretty familiar with this function. It's x squared. All right, and pretty much here you can kind of see that. So I can do some color coding here. Across the axis right here, so your y-axis, you can see that this side right here, it looks like a mirror image of this side right here, right? So whenever you see like a mirror image, right, across a certain axis, we say that we have symmetry, okay? This could also happen in different cases, so you can also have a case where uh, you have symmetry across the x-axis as well, right? So here we would say we have symmetry about the x-axis, okay? And then finally you have some other cases where you can have symmetry across the origin, right? So pretty much looks like that, right? So you can have symmetry like this, where it's kind of like a combination of both, right? So imagine you had a mirror image. Let me see if I could illustrate this. Let's say you had a mirror image right here, and then let's say you had another mirror image to this one across the x-axis, right? And that would actually get you this. So you can see it's kind of a combination of a x-axis and a y-axis symmetry, okay? So, so pretty much that covers the three types of symmetries when we look at Cartesian coordinates. So this would be y-axis symmetry. This would be x-axis symmetry. Whoa, did not. Okay, x-axis symmetry. And this would be origin. Okay, cool. So, so yeah, those are the three different types. Like I said, if you have y-axis symmetry, it's called y-axis because it's symmetry about the y-axis. Here it's about the x-axis, that's why it's called x-axis symmetry. And then of course you have the origin, which you would look right here in the center, where it's like kind of combination, right? Across the origin you have a symmetry, right, like that, okay? So so let's go ahead and get into it. So that's how you could tell what kind of symmetries you have through just graphs. But let's go ahead and get into some actual equations, okay? So let's say we had the equation y equals x squared, okay? So we're actually going to go ahead and use this as our first example, okay? And that's just because I want you to know already what symmetry we do have. And that way when I introduce it, you kind of know what the answer is going to be, and you'll see why uh, it it's it has a symmetry or not, okay? So let's start off with our rules, right? So first of all, when you're testing for symmetry, um, your goal is to get back to your original equation, okay? And I'll let you know what I mean by that, but that's your goal, right? So first of all, if we are going to test for, um, let's say we're going to test for, let's say, x-axis symmetry, all right? If we're going to test for this, we are going to plug in where y goes, we're going to plug in a negative y, okay? So what I mean by that is we're going to take a negative y and put it right there where the y was, okay? So let's go ahead and do that. So let's plug in negative y, and then we'll just rewrite everything else the same, okay? So when I was saying our goal is to go back to our original equation, I mean exactly that. We're trying to take what we just plugged in here and we're trying to see if we can in any way use algebraic tricks or manipulation to get back to this original equation, okay? So here, let's go ahead and try a few different things. So we see that this y has to be positive, so so someone might say, well, why don't we just divide everything by -1? That should turn in positive, right? So let's go ahead and do that. So if we divide this by -1, we must also divide this side by -1, right? So when we divide this side by -1, we do in fact get a positive y on the side. But what happens over here is that you turn this side into a negative x squared, okay? And then someone might say, well, then just divide by -1 again, and then you can do that. But as you'll see, you'll kind of go into a loop, right? Here you turn it back into a positive x squared, and this one will turn back into a negative y, right? So you can try that, but you're just going to end up in a loop, and you'll never get out of this one. So here we would say that we do not have, well, I guess that's not really useful, right? We'll say we do not have x-axis symmetry, okay? So that's our test for x-axis. You would say no symmetry across x. Next, let's test for y-axis symmetry. And this is the one we know we should have, right? So let's see why this happens. So with y-axis symmetry, oops, so y-axis, whatever, we plug in, well, as you might expect, negative x for where x was, okay? So we're going to take negative x and plug it in where our x used to go, okay? So let's go ahead and plug it in. So we have y is equal to negative x squared, okay? And it's important you guys know how to plug this stuff in, because where x used to go, remember, all of this used to be squared, right? So when you plug in a negative x, you must also put all of that into a parentheses as well, okay? So let's see why this works out. So if we were to try to simplify this, we could, right? We have technically, I guess you could rewrite this. Let's see if this helps you guys understand this a little more. You could rewrite this as -1x squared, right? And you can use your distributive, I guess, property for powers, and you can distribute this 2 to both the -1 and the x. So then you would end up having -1 squared times x squared, right? And what happens here with the -1x, what happens here with this -1 is that it turns into a positive, right? So -1 times -1 makes it a positive one. So you can see here that we in fact do get our original equation back, right? Of course it has like a 1 in front of here, but we could pretty much ignore that, right? 1 times anything will just give you the same thing. So you could just ignore this stuff, and you can see that we do have our original equation back, okay? So the test actually does confirm that we do have y-axis symmetry, because when we plugged in negative x, we were able to simplify to get our original equation back, which was y equals x squared, okay? So that's pretty much why it does have y-axis symmetry. I'm just going to go over the origin real quick. Oops, I don't know how to spell origin. Whatever, sorry, it's ugly. So for origin, remember how I said it was kind of a combination of x-axis and y-axis symmetry? Well, pretty much you're going to combine these two tests. So you're going to plug in both -y and -x, right? So we'll plug in -y, and we're going to have a -x in here as well, okay? So let's go ahead and try to simplify. We can't really do much with the -y, so we'll leave it like that. But this -x squared, from what we saw, ends up turning into a positive x squared. And as you can see, we end up having the same problem we had over here with the x-axis symmetry, right? So, we're going to end up having no symmetry as well here, okay? So because we weren't able to get it back to the original equation, we also do not have x-axis symmetry, okay? So just to recap, right? To test, you have to plug in, so we plug in -y or -x, depending on which test, right? So depending on which test you use, you're going to plug in negative y or x, okay? So for x-axis, you're going to plug in the opposite, so negative y. For y-axis, you're going to plug in the opposite, so you're going to plug in negative x. For origin, it's a combination of both, so you're going to plug in both negative y and negative x, okay? Let me know if you guys have any questions on this stuff. I will make another video right now to give more examples, just because this video is getting a little long, okay? So I'll make another video if you guys want to see more examples. Hopefully that helps click, but definitely this is something that is a little tricky at first, especially if you're not used to manipulating equations, okay? Well, let me know if you guys have any questions, alright? Cool. See you.